After studying this module, you shall be able to learn about Curie-prigogine principle, relate scalar flows with vectorial forces and vice versa, know about the phenomenological equations, and learn about the principle of microscopic reversibility. Curie-prigogine principle. In the equations, Gi represent the flow and Ri represent the corresponding forces. The coefficient Lik is equals to Ji upon Xk at constant Xj are the flows per unit force, and Rik is equals to Xi upon Jk at constant J are the force per unit flow. In the equations, the assumptions was made that there is a linear coupling between all forces and all flows, which are taking part in irreversible processes occurring in a system. For different flows and forces, there is a requirement of different assumptions. The flow of chemical reaction and thermodynamic force associated with it and the affinity of the reaction are scalar quantities, while the flow of heat and matter as well as their conjugated forces are vectors. Viscous phenomena, which are omitted in this treatment, are tensor of second order. According to this Curie principle, the dissipation function is given by phi is equals to summation of Js into Xx plus summation of Jv into Xv, where Js are the scalar flows and Xx are their conjugate forces. Jv are the vectorial flows with Xv corresponding conjugate forces. On simplification, we can write the equation as phi is equals to summation of Js into Xs plus summation of Jv into Xv, where the S is changing from 1 to 3 up to k and V is changing as k plus 1, k plus 2 up to h. To know whether coupling exists between the flows of one character and forces of another character, consider that x component of any flow can be coupled with x component of a force of any tensorial order. A scalar is a tensor of 0th order, vector is a tensor of first order, and tensors of higher order may also occur. According to this, we can write phenomenological equations as Js is equals to Lss into Xs plus Lsv into Xv, and another equation which is Jv is equals to Lvs into Xs plus Lvv into Xv. In the above set, Lss relate the scalar forces Xs to the scalar flow Js and itself is scalar quantity. The coefficient Lsv must be vector to give scalar flow through inner product with vectorial force Xv. The coefficient Lvs must be vector in order to produce a vectorial resultant Jv when multiplied by scalar Xs. The coefficient Lvv is a tensor of second order which transform the vectors Xv into vector Jv. Such couplings occur in an anisotropic system in which there is no spatial symmetry, but for isotropic system in which the properties at equilibrium are same in all directions, all modes of coupling are not possible. Thus, flows and forces of different tensorial order are not coupled. Therefore, for isotropic case, the equation reduces to Js is equals to Lss into Xs since Lsv in equation 3 is 0 and Jv is equals to Lvv into Xv since Lvs in equation 4 is 0, where the coefficient Lvv is scalar. The reason for this behavior is that In isotropic system, a reversal of sign of all coordinate axes must leave all phenomenological coefficients invariant. Since LSS is scalar, which is also required, but the vectors LSV and LVS change their sign upon inversion to the coordinate system. LSV and LVS remain invariant only when both are equal to 0 or if no coupling exists between scalar flows and vectorial forces and between vectorial flows and scalar forces. As LVV should be invariant under any rotation of coordinate system leads to conclusion that LVV must be scalar for isotropic system. Thus, the Curie-prigogine principle states that there is no coupling between scalar and vectorial quantities since it is based on considerations of Curie regarding cause and effect relation in static system of different symmetry. It was extended by Prigogine to irreversible system in flow. Important conclusion from this principle is that simultaneous diffusion and chemical reaction cannot be coupled phenomenologically in an isotropic system. Principle of microscopic reversibility. The principle of microscopic reversibility states that mechanical equations of motion of individual particle of a system of particles are invariant with respect to the transformation or reversal of time. That is, this principle of microscopic reversibility is a consequence of the invariance of the equations of motion under transformation of time, which simply means that for every microscopic motion, if all the velocities of particles are reversed, then also solution is obtained. Now generalizing the concept of correlation fluctuation, consider a fluctuating parameter alpha I which have the values alpha I at time t and fluctuation alpha j after time tau, and then the product of both these quantities is taken. So, the average value of this product during a sufficiently long lapse of time is given by equation 7. That is, the time average is also equal to the ensemble average according to ergodic theorem. This principle on microscopic level also states that the processes which are going in one direction have the same probability to go in opposite direction, or we can say that the arrow of time has no direction in microscopic realm. In the fluctuation, alpha jt and alpha I t plus tau are considered, the later occurring after the time interval tau. Then average value of the product of alpha jt and alpha I t plus tau are found. This differs from equation 7 only in the order of two fluctuations or by substitution t as minus t. Thus, the microscopic reversibility can be expressed as equation subtracting alpha it into alpha jt from both sides and then dividing by tau, we have equation 9. When t approaches to 0, that is tau tends to 0, we get equation 10. Tau are physically small for smallest value, but they should be large enough compared to the time of single collision process, tau naught, as it is the only case in which the statistical average is applied. But if values of tau are very large, then they should not be larger than the time required for the fluctuation to relax and disappear, as at larger values of tau becomes meaningless. Thus, the relation should be tau naught should be much less than tau, which is much less than tau r. introducing Onsager hypothesis, which states that the rate of change of fluctuating parameter has same linear dependence on thermodynamic forces as observed in macroscopic flows. Mathematically, it can be written as equation 11, in which Lik are the overall macroscopic coefficient. Now substituting equation 11 in 10, we get equation 12. Using result of fluctuation theory, ultimately we get equation 14, where k is a constant and delta rho prime rho is the Kronecker delta. That is, the value of Kronecker delta is equals to 1 when rho prime is equals to rho and is equals to 0 when rho prime is not equals to rho. Thus, from equation 12 and 14, we get Lji is equals to Lij. These are Onsager reciprocal relations. Such relations are also valid for systems which have systematic deviations from equilibrium till the linear relationship between fluxes and forces is maintained. The extension of Onsager theory to complicated system has been done by Casimir and de Groot. Now let us summarize. According to the Curie principle, the dissipation function is given by the sum of summation Js into Xs plus summation Jv into Xv, where Js are the scalar flows and Xs are their conjugate forces. Jv are the vectorial flows with Xv corresponding conjugate forces. Flows and forces of different tensorial order are not coupled. Curie-prigogine principle states that there is no coupling between scalar and vectorial quantities. Important conclusion from this principle is that simultaneous diffusion and chemical reaction cannot be coupled phenomenologically in an isotropic system. The principle of microscopic reversibility states that mechanical equations of motion of individual particle of a system of particles are invariant with respect to the transformation or reversal of time. The Onsager reciprocal relation is given as Lji is equals to Lij. Such relations are also valid for systems which have systematic deviations from equilibrium till the linear relationship between fluxes and forces is maintained.